Ever heard of something that came from the deep unknown and left us with more questions than answers? In 2017, a mysterious object shot through our solar system at an insane speed. Named Oumuamua, Hawaiian for a messenger from afar arriving first, it was the very first interstellar object humanity had ever detected. But by the time we noticed it, it was already waving goodbye. Now here's the kicker. Even now, we still don't know exactly what it was or where it came from. Welcome to Curiosity Echo. If you're into deep space mysteries and mind-bending celestial discoveries, you're in the right orbit. And hey, if you enjoy content like this, hit that subscribe button and ring the bell so you never miss the next cosmic puzzle we crack. So what do we actually know about Oumuamua? It was discovered by the Pan-STARRS 1 telescope in Hawaii, and estimates suggest it's somewhere between 100 and 1,000 meters long. Based on light reflection, it could be shaped like a flattened disc or an elongated cigar. Pretty standard interstellar object stuff, right? Wrong. Things got weird when it zipped past the sun. Instead of slowing down like any rock should under the sun's gravity, it accelerated, with no visible tail, no coma, no sign of outgassing. Essentially, none of the behavior we see in comets. Rob Warwick, the astronomer credited with its discovery, put it simply, its motion couldn't be explained by any natural orbit we've seen before. So what was it? An asteroid? A comet? Or something artificial? Some scientists believe it's not impossible that Oumuamua could be a fragment from an alien probe or an interstellar light sail. Sure, it's a bold idea, but what else could explain the sudden burst of speed without visible propulsion? Tracing its trajectory, it seems to have come from the general direction of Vega in the Lyra constellation, about 25 light-years away. But that's far from a confirmed origin. It's already over 6 billion kilometers away, speeding toward the Pegasus constellation at 26 kilometers per second. And here's the million-dollar question: can we catch up to it? Turns out, some researchers think we can. Enter Project Lyra, an ambitious proposal to intercept Oumuamua using extreme propulsion techniques. The concept involves using gravity assists, slingshotting around planets to gain speed, and possibly even a solar Oberth maneuver, where a spacecraft dives close to the sun and fires its engines at maximum velocity. This maneuver could fling a probe out of the solar system at over 70 kilometers per second. That's fast enough to catch up. The tech challenges? Enormous. We'd need serious heat shielding, flawless trajectory planning, and next-gen propulsion systems. But technically, it's doable. An alternative path uses Venus and Earth flybys before slingshotting past Jupiter. This avoids needing a heavy heat shield and would make it easier to slow down and study Oumuamua up close. Slower, yes, but far more manageable. The timelines? If launched between 2030 and 2033, such a mission could reach Oumuamua around 2048. Not exactly fast, but definitely within our lifetime. But do we even need to chase it? Some argue we should focus on being ready for the next interstellar visitor. NASA believes objects like Oumuamua pass through our solar system roughly once a year. We just don't notice them in time. That's where the Vera C Rubin Observatory comes in. Set to go online soon, it could spot interstellar interlopers months earlier than before, giving us time to react. This is a game changer. With a field of view large enough to scan the entire sky every few nights and a 10-year mission plan to build a database of over 2 million images, the Rubin Observatory's legacy survey of space and time could allow us to detect dozens of Oumuamua-like objects every year. In fact, a 2023 study predicted the LSST could identify up to 70 interstellar objects annually. That's a dramatic increase from our current capabilities, and it could shift how we study such mysterious visitors. Rather than chasing after one elusive object years after it passed by, we could study them in real time, multiple times a year. ESA is also stepping up the game. Its Comet Interceptor mission, set to launch in 2029, will be parked in a stable orbit waiting for an undiscovered comet or interstellar object. Once one is detected, it will leap into action and attempt a high-speed rendezvous and flyby, capturing the first-ever close-up images of an untouched foreign object entering our system. The Comet Interceptor will carry 3 spacecrafts working together to map, image, and analyze the object in incredible detail. It's a perfect mission for an unpredictable visitor, and it marks a shift in our mindset from reactive observation to proactive interception. But here's the catch. These missions won't give us any new data on this object. Oumuamua is already too far for telescopes to study it properly. If we want answers, we have to chase it down. It may cost time, money, and a whole lot of engineering brilliance, but is it worth it? Project Lyra certainly thinks so. They argue that an interstellar pursuit mission, despite its challenges, is well within our reach and would offer unprecedented scientific returns. Not only could we finally solve the mystery of Oumuamua, but we'd also test technologies and maneuvers that could be crucial for future interstellar exploration. And there's more. Since Oumuamua, we've detected a second interstellar object, 2I/Borisov, which behaved more like a traditional comet. But the more we observe, the more we realize how little we understand. Oumuamua might have been the tip of the iceberg. Oh, and before we wrap things up, remember how I mentioned Oumuamua's strange acceleration? Turns out it's not the only one. 6 other small bodies have shown similar behavior. They're being dubbed dark comets. Could they be related? Are they fragments of a larger interstellar traveler? Or just cosmic coincidence? That opens up a whole new set of questions. Are dark comets a new class of object? Could they offer clues about the composition of exoplanetary systems? Or are we witnessing effects that challenge our understanding of physics itself? That's a story for another time. So if you want to dive deeper into the mysteries of space with us, make sure to like this video, subscribe to Curiosity Echo, and ring that bell so you don't miss what's next. See you out there, fellow stargazers.